Here's the aforementioned optional video. Where does the integrating factor come from? Remember, we said that with the appropriate integrating factor, mu m dx plus mu n dy equals 0 is exact. Well, if it's exact, then that means that the partial of mu m with respect to y is equal to the partial of mu n with respect to x. Each of these is a product, so we apply the product rule on both sides. The partial of mu with respect to y times m plus mu times the partial of m with respect to y equals the partial of mu with respect to x times n plus mu times the partial of n with respect to x. Now we're going to gather the mu terms together on the right-hand side. The result is going to be mu ym minus mu xn is equal to nx minus my times mu. If it turns out at this point that mu was a function of both x and y, then what we have is a partial differential equation that's not for this class. So for us to be able to proceed, mu has to be a function either of x or of y. Suppose mu depends only on x, so I've written mu equals mu of x. Then the partial of mu with respect to y is equal to 0. And then we have the partial of mu with respect to x divided by mu is equal to the partial of m with respect to y minus the partial of n with respect to x divided by n, just by rearranging this stuff with mu with respect to y equal to 0. This is going to give us the natural log of, I'm going to drop the absolute value here because we know what's going to happen. The natural log of mu is then equal to the integral of the partial of m with respect to y minus the partial of n with respect to x over n with respect to, remember this assumption was mu is only a function of x. So this is with respect to x. And that's going to give us that mu is equal to e to that integral, which is what we had before. If instead mu had been a function of y, then going back to that equation, the partial of mu with respect to x would have been the one that's 0. And we'd have that mu with respect to y over mu is equal to the partial of n with respect to x minus the partial of m with respect to y divided by m. And that would lead us to mu is equal to e to the integral of n with respect to x minus m with respect to y all over m. And again, this is the one where mu was a function of y.